Welcome. In this video, we're going to look at different conics and we're going to determine what type of conic it is as well as state the orientation. Now, in order to state the orientation in a lot of these situations, we need this in standard form. All right, so for example A here, we're given 3x squared or negative 3x squared minus 3y squared plus 75 equals 0. Now, because we have an x squared and a y squared, then we know we do not have a parabola presented. All right, now let's look at the signs. We have both an x squared and a y squared. Because they have the same signs, either both positive or both negative, we know that it's not a hyperbola. And those signs could either be both positive or both negative, right? But if they're opposite signs, that would have indicated this is a hyperbola. So that means we're either dealing with a circle or an ellipse. An ellipse will have two different coefficients, whereas a circle is an ellipse where the minor and the major axis, they all have the same radius, right? So we know this is a circle. Now, in order for us to finish this problem, we're going to put it into standard form. Remember, a circle doesn't have orientation because it's got a constant radius as opposed to an ellipse having a minor and a major axis. But a circle in standard form is going to be x squared plus y squared equals r squared. And of course, we could have coefficients in there if we needed. But what I'm going to do is I'm going to go ahead and move this constant term over to the right side of the equation. So negative 3x squared minus 3y squared equals negative 75. Then I'm going to divide everything by negative 3 because I've got that common factor on the left. So that gives me x squared plus y squared. Now both of those are positive, equals positive 25. So this is the same as x squared plus y squared equals 5 squared. This represents a circle of radius 5. And of course, since there's no plus or minus, h or k value attached to these x and y, this is a circle of radius 5 centered at the origin. All right, let's look at another example. For example B, we have x minus 4 plus 4y equals y squared. So identifying the conic, this is either a parabola, circle, ellipse, or hyperbola. And right away we see that there's only one squared term. There's only one squared term. That means this is going to be a parabola. And since it is y squared, it's a horizontal parabola. That means my parabola is either going to open to the left or would open to the right. So our standard form for a horizontal parabola is going to be y squared equals 4px, or rather y minus k quantity squared equals 4px minus h. So I need all my y terms on one side of the equation. I'm going to kind of rearrange it to organize it in this fashion. So beginning to organize it so we can complete the square, I've got both my y terms. So that's y squared minus 4y, and that's equal to x minus 4. We need to come up with our magic number, and that gives me y squared minus 4y plus 4 equals x minus 4. Because I add 4 to the left, I'm also going to add 4 to the right, and we'll see those 4s will cancel out. So the left side, we can complete that square, and we'll say y minus 2 quantity squared equals x. So now we have it into almost standard form, but almost standard form means that that coefficient in front of x, we need to represent that as 4 times p. Currently, the coefficient we have here in front of x is a little invisible 1. Therefore, what we know is that 1 must equal 4p, which lets me know that P equals 1/4. So putting this into standard form, 1 minus 2 squared equals 4 times positive 1/4 times x. So this is a horizontal parabola. It opens to the right because P is positive, and that xy ordered pair is going to be 0, 2. That is my vertex. 0, I've got minus 0, and then minus 2, we've got positive 2. And then the directrix would be 1/4 of a unit behind it, and the focus would be 1/4 of a unit inside. That P value tells us about the directrix and the focus. All right, let's look at example C. So again, identifying what this is, we have x squared equals 4y squared minus 36. First thing we notice is both x squared and y squared. And that means this is not a parabola. If this is not a parabola, then we know it's either a circle, an ellipse, or a hyperbola. Noticing on both of our x squared and y squared terms, we have different coefficients. That lets me know it's not a circle. And if it's not a circle, it must be an ellipse or a hyperbola. Now, ellipses have the same signs, and hyperbolas would have different signs. And at first glance, you might think that this is an ellipse because they're both positive. They both have the same sign. However, when we keep in mind our standard form, the standard form has both the x squared and the y squared on the same side. So this is actually x squared minus 4y squared equals negative 36. And since when they are both on the same side of the equation, we have different signs, that lets me know this is not an ellipse. It is a hyperbola. Now, orientation. This is x squared minus y squared. So I might think this must be horizontal because x squared minus y squared is a horizontal transverse axis opening to the left and right. And y squared minus x squared would be a vertical transverse axis, and that hyperbola opens up and down. However, standard form needs to be equal to positive 1. So what will happen to these two signs when I divide on each side by negative 36? So what's going to happen is we're going to have some sign changes. That's going to give me negative x squared over 36 plus y squared over 9 equals 1. So really working to get that into standard form, that would be y squared over 9 minus x squared over 36 equals 1. So that means because it is y squared minus x squared, this is going to be a vertical hyperbola, which means we have a vertical transverse axis, and that hyperbola opens up and down. While we're at it, what are the a and b values? Got y squared over 3 squared minus x squared over 6 squared. Now, with an ellipse, a is larger than b, but with a hyperbola, a comes first. So a is 3, b is 6, and the c value, that would be c squared equals a squared plus b squared. So we could calculate the c, which would help us with our foci. So this is my vertical hyperbola in standard form. Let's look at one last example. For our fourth example, D, we have y squared equals 16 minus 4x squared. Right off the bat, we know this is not a parabola. It's not a parabola because we have both x squared and y squared. I'm going to go ahead and get this into standard form because the circle and the ellipse and the hyperbola, they all look pretty similar. So I'm going to move that 4x squared over, which gives me 4x squared plus y squared equals 16. Since we have different coefficients, we know this is not a circle. Since we have the same sign, we know it is not a hyperbola. That means what we are dealing with here is an ellipse. Moving through this, we'll continue to put it into standard form. And in standard form, we need it to be equal to 1 for an ellipse or a hyperbola. So this gives me x squared over 4 plus y squared over 16 equals 1. Or taking that standard form one step further, 2 squared in that denominator and 4 squared. Now, is this a horizontal or a vertical ellipse? Because the operation between these squared terms is plus or addition, we don't have any orientation to let us know, right? We have to look at the larger of the two values. So with a hyperbola, it's which comes first. The order matters when we're subtracting. But here, we don't have any specific order because I could reverse these and it would mean the same thing. So the larger number, this means we have a vertical, I should say vertical because it's under y, a vertical major axis ellipse. So in this situation, again, we have a vertical transverse axis or major axis ellipse. My A value is the larger 4. My B value is the smaller 2. And then we find C by saying A squared minus B squared equals C squared. So I hope that helps you see all of these conics together and be able to develop your strategies for attacking these problems, right? We need to be familiar with how we want these organized in standard form and then all of the different nuances that create the different types of conics. As always, email me with any comments, questions, concerns. Good luck out there.